Hello and welcome back to my series where I'm modelling how to tackle some of these really challenging calculations that we find in our quantitative chemistry topic at GCSE. In this video, I'm going to model how we can use our ideas and understandings about the mole in order to calculate the limiting reactant in a reaction. So first of all, we need to know what we mean by the limiting reactant. The limiting reactant is the one that is used up first in the reaction. So if one of our chemicals is in excess, that means we've got more than enough of it and there'll be some left over. The other one will be the limiting reactant, where it will get used up first because it limits how much product we can make. So let's have a look at the question in front of us. The balance symbol equation shows us the reaction between aluminium and chlorine to produce aluminium chloride. 810 grams of aluminium reacted with 3.25 kilograms of chlorine. Calculate and explain whether aluminium or chlorine is the limiting reactant in this reaction. And again, we've been given the atomic masses of aluminium and chlorine to help us. But remember, if they're not given for you in the question, then you can always find them on your periodic table, which you'll have with you in an exam. So as always, we need to bug the question and read through it again. So 810 grams, so I'm going to circle that number there. And this time, this is given for us in our standard unit that we use in chemistry calculations of grams. Of aluminium, we need to underline the name of our key reactant, is reacted with 3.25 kilograms. Let's circle that. And I'm also just going to sort of underline the kilograms there because you can see we've got a difference in the unit that we're using for mass here. So we're going to need to think about doing a cheeky little conversion at some point to get those the same. So 3.25 kilograms of chlorine. Calculate and explain. So we've got two command words there. Calculate, we're going to need to do some maths in this, but we also need to explain. So that means towards the end, we're going to need to write a sentence or two to explain what our calculations show. So calculate and explain whether aluminium or chlorine is the limiting reactant in this reaction. Okay, so now we've bugged the question, we can have a go at starting to answer it. We only really need to worry about aluminium and chlorine. We don't need to worry about the aluminium chloride in this reaction. And we're going to be using our equation mass equals moles times mR in order to solve this particular equation. Okay? So, in order to compare these two chemicals, we've been given the masses, but in order to compare which one is the limiting reactant, we need to calculate the number of moles of each of our reactants. I'm just going to move my camera slightly here. So just as a reminder, to calculate the number of moles, we need to rearrange this equation. We need to divide both sides by the mR, and that gives us mass over mR equals moles. Okay, so let's deal with these two chemicals separately to start off with. So we've got our aluminium, and we've been told we've got 810 grams of aluminium, so that's already in grams, we don't need to convert it. And in order to work out the number of moles, we need to divide it by its mR. Now remember, because it's just the metal by itself, we just use its atomic mass in order to calculate the moles. So we do 810 divided by its atomic mass, which is 27. So we pop that into our calculator. 810 divided by 27. And that tells us that we are using 30 moles. So we've got 30 moles of aluminium. Okay, so we'll leave that there for the moment. Let's deal with our chlorine. Now it is Cl2, so we do need to take into account the fact that it's a molecule. But if we have a look at our question, we've got 3.25 kilograms. So the first thing we need to do is to do our cheeky little conversion. And you should know by now that there are 1,000 grams in a kilogram. So 3.25 times 1,000 will give us 3,250 grams. Now we've got it in grams, we can divide it by the MR to work out the number of moles. Okay. However, we do need to work out the MR of chlorine because it's Cl2. So the MR of chlorine will just be 35.5 plus 35.5. And so if we do that in our calculator, that gives us 71. So the MR is 71. So now we can do the grams divided by the MR, and that will give us the number of moles. So 3,250 divided by 71. Okay, and that gives us 45.77 moles. Now, at this stage, what you might be tempted to do is just compare those two mole numbers that we've got and say, well, aluminium has fewer moles than chlorine, therefore it's the limiting reactant. Unfortunately, it's not quite that simple, because if we just move back and have a look at our balance symbol equation, you can see that 2 lots of aluminium react with 3 lots of chlorine. So we need to take into account that molar ratio. Now there's 2 ways you can do it. I'm going to start off with the aluminium. Okay, so what we need to do is work out how much chlorine could react with the 13 moles of aluminium. Okay, so I'm going to write a little sentence underneath. Aluminium could react with, and so we need to do a little calculation. Okay, it's a 2:3 ratio that we can see from our symbol equation. So if we do 30 divided by 2, that will give us 15. And then if we do 15 times by 3, that will give us, just double check on the calculator, 45. So what we're saying is that the 30 moles of aluminium could react with 45 moles of chlorine. And your final step is to compare that to how many moles of chlorine we actually have. Okay, and here's where the explanation comes in, because we need to explain which is the limiting reactant. Okay, so my second part of my sentence will be something like, however, we have 45.77 moles of chlorine, which shows, so we've got more than enough chlorine compared to what we need. We would only be able, the aluminium could only react with a maximum of 45 moles. So that tells us, because we've got more than enough chlorine, that's in excess. So this shows that aluminium is the limiting reactant. Okay, so let's just go through the question again and see where we would pick up those 5 marks. I'm just going to move it up slightly. So you would get 1 mark for calculating the number of moles of aluminium, doing the mass divided by the relative formula mass, the MR. You would get 1 mark for doing the conversion of kilograms into grams. Okay. You would get 1 mark for dividing that by the MR and working out the number of moles of chlorine. You would get 1 mark for understanding that we needed to use the molar ratio. So that's this bit down here. So I've divided the aluminium by 2, times it by 3 to work out how much the chlorine could react with. Now you could have done this the other way around. You could have worked out how much aluminium the chlorine would have reacted with, but it would have still given you the same answer. You still would have found that aluminium was the limiting reactant. And your final mark is for the explanation. However, there is 45.77 moles of chlorine, which shows that aluminium is the limiting reactant. So 1 mark for the explanation there. Okay. Sometimes, depending on the complexity of the question, you may also actually get a mark for calculating the MR of one of your compounds as well. Okay. So there we have it, our 5 marks using our mass equals moles times MR equation and using the molar ratio to work out what the limiting reactant is in a question. Hope you found that model answer useful, and I shall see you next time, where we'll be looking at using the molar ratio and the mole calculations to decide on the correct balanced symbol equation for a reaction. See you next time.